Today we're going to learn 3 different ratios that you can use when trying to solve for side lengths or angles of right triangles. So the 3 ratios we're going to learn are called sine, cosine, and tangent. So let's talk about tangent first. So the tangent of angle A is equal to the length of the leg that's opposite angle A over the length of the leg that's adjacent to angle A. And hopefully you remember that adjacent means like next to or beside. So adjacent to angle A. And we can abbreviate that, since that's a really long formula to have to write out all the time. We'll abbreviate it as tan A, so that means the tangent of angle A, is equal to opposite, which I'll abbreviate OPP, over adjacent. So let's do an example of a problem like this. If I give you a right triangle, and I will tell you that this is a right triangle with a little box there, and for argument's sake we'll just label this VUT, and we'll say this is 3, 4, and 5. So the first thing that you have to note is that you're going to ignore the 90-degree angle. You're not going to use a tangent, a cosine, or a sine ratio on the 90-degree angle. And so when we're looking for, let's say, the tangent of t, we know that the tangent is equal to opposite over adjacent. So we're going to start at the angle t, right? So if we're looking at this angle, we know that 4 is adjacent. We know that 5 is the hypotenuse. We know that 3 is opposite. So now we can just plug in our numbers. Opposite is 3, adjacent is 4. So the tangent of t would be 3 over 4, that ratio. And if you want to star this and put a little side note in, you can say that the hypotenuse is never considered adjacent or opposite. Considered, sorry, I'm writing on top of each other, adjacent or opposite. And so if in a formula we wanted the hypotenuse, we would specifically ask for the hypotenuse. But when we say adjacent or opposite, it's never going to be the hypotenuse. So be careful for that trap. The next one we can do is the tangent of u. So the tangent of u, we know again, will be opposite over adjacent. So we go ahead and look at angle u. So now the sides are not going to be the same. 4 is opposite to u, and 3 is adjacent. 5 is still the hypotenuse. So now we know that we're looking at 4 over 3 as a ratio for our tangent of u. So hopefully that makes sense. Let's move on to the sine. So the sine of angle A is equal to the length of the leg opposite angle A over the length of the hypotenuse. And we're going to abbreviate this one again by sin A equals opposite over hypotenuse. Much easier to write when we're writing all of this out to show our work. So again, let's look at an example. We're going to draw a right triangle, and we'll label this one ABC, and we'll, oops, see, and we'll say this is 7, 9, and 12. So if we're looking at the sine of B, again, we know that that would be opposite over hypotenuse. So if we look at purple for B, if we're looking at B, we know that 9 is opposite, we know that 7 is adjacent, and we know that 12 is the hypotenuse. So the sine of B would be the opposite over the hypotenuse, so it's going to be 9 12. 9 over 12. Similarly, we could look at the sine of c. Again, that's going to be opposite over hypotenuse. So if we look at blue for c, we have c. Now we have 9 as the adjacent, 7 as the opposite. 12 is still the hypotenuse. So now we have the sine of c is equal to opposite, so 7 over the hypotenuse of 12. If we wanted to, we could go back and look at the tangent in this triangle. So the tangent of b, remember the tangent is equal to opposite over adjacent. So the tangent of b would be equal to 9 over 7. Alright, we have one more to learn, and that is cosine. So the cosine of angle A is equal to the length of the leg adjacent to angle A over the length of the hypotenuse. And we'll abbreviate this one. Cos A equals adjacent over hypotenuse. So now let's go ahead and do an example of this one. If we draw a right triangle here, and we'll label this one cat because that'll be fun. And we'll put this as 4, 7, and 19. So the cosine of A is equal to adjacent over hypotenuse. So if we're looking at A, 4 is adjacent, 7 is opposite, 19 is hypotenuse. So the cosine of A is equal to 4 over 19. So hopefully that makes sense. The trickiest part, in my opinion, is remembering the different formulas for these. So if I were you in your notebooks, I would write down this funny word that everyone has come to love, and it's SOHCAHTOA. And for me, it helps to separate the three words just to keep them all straight. So we have so, and then ka, and then toa. And these words stand for the formulas that you just learned. So this one stands for sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. And finally, tangent equals opposite over adjacent. That looks weird. But anyway, hopefully that will help you keep those formulas straight. So let's see if we have time to do one example. So this would be an example where you're trying to solve for a side length. So let's go ahead and draw this triangle. We'll make it a 90-degree angle, and we'll label it, let's label it cat again. And we'll say that this is x and this is 7. And I will tell you that angle T is 80, no, it's not 82 degrees, that would look weird. Let's say that angle T is, I don't know, 62 degrees. Okay, so if we're looking at angle T, that's the angle that we're given. So we're looking at angle T, 7 would be adjacent, and 8 would be opposite. So now write down your SOHCAHTOA up at the top. SOHCAHTOA. So you know that you have an A and an O. So you're looking for a function that has an A and an O in it. And the only one that does is TOA. So we're going to use tangent. So we're going to write the tangent of T is equal to opposite over adjacent. We're going to write the tangent of 62 is equal to opposite, which is x, over adjacent, which is 7. And now you just solve for x. So we're going to multiply both sides by 7 to get 7 out of the denominator. we're left with 7 times the tangent of 62 degrees equals x. And then you can just plug that value into your calculator, and you should get, hang on one second please. So we do 62 times 7. Oops. So it should be about 13.165 is equal to x. So that's telling you that this side length is 13.165. So I'll do another video that has more examples, but hopefully that helps for now.